So 4.5, integration by substitution. We're going to recognize patterns. We're going to do some substitution. Okay, so far when we've done integration, when we've had like a rational function, you had to divide it out so you could just integrate each piece. We're going to integrate by substitution now so we don't have to do that. Cross our fingers. So, remember the chain rule? Yes? The chain rule we should know? Mm-hmm. So, we had a function in another function, correct? Mm-hmm. So, we took the derivative of the outside function and times it by the derivative of the inside function. Mm-hmm. So, similar to that. So, the anti-differentiation of a composite function. So, we have to go backwards. We have to go from here to here now. Okay? Let G be a function whose range is in the interval, and let F be the function that is continuous on the interval. That's all that kind of blah, blah, blah stuff, right? So what we have, and I'm going to be talking about this piece right here, is we have the integral, and then we have, this is the chain rule right here, isn't it? Yes? So this is the derivative of the outside times the derivative of the inside. So we're going to go backwards, and we're going to have it end up here. So how we do that is we let u, we're going to do u and du. It's going to be a thing that just rolls off your tongue soon. U is g of x. So g of x is right here. See that? Okay, u is g of x. D stands for what? What's D stand for? Derivative of u is right here. So we take something that looks like this here, and we change it so it looks like something like this. Doesn't this look much easier to take the derivative of? Yes. Yes. Because that gives me the integral of. It gives me one thing I have to take the integral of, doesn't it? So we will find an answer, and then we have to substitute back in, guess what? What is this? U. We'll substitute back in u. Tell me when you guys are ready. And the examples are going to be much more to you than what we just did. Like always, right?
So yes, we already have that top part.
Yes.
Mm-hmm.
Okay, we're good? Okay, so the example, we have the integral of 2x times x squared plus 1 squared. So before today, you had to FOIL out this x squared plus 1, right? Mm-hmm. And then you'd have to multiply it by 2 just in order to take the integral of the 3 different chunks. And we don't want to do all that work, do we? No. So what we are going to do is we are going to break these things up. I want to see how far I want to go today. Okay, so f of x. Okay, f of x was the outside function, correct?
Yes.
Yes. F of x is what? What's the outside function?
2x.
What's the outside function?
2x, x
No,
squared,
just
squared,
x squared. Outside function is x squared. Do you see that? You're looking for the compound part. I guess maybe I need... Did you see this is the compound function part? See that?
Yep.
Okay, so the outside is x squared. The g of x was the inside. And what's the inside function?
X squared plus 1. Yeah.
Okay, so x squared plus 1.
So then is 2 just the constant? Like, is it going to be out of the...
I get what you're saying. I'm trying to think about how to answer that.
I get that. That means I asked a really good math question. Very proud.
You can pull it out if you would like. But you do not have to.
So then where does it go if we don't? Is it an outside function or is it an inside?
Okay, well, this right here is actually this, correct? Isn't it?
What? Say that again. Wait, say that again.
Oh, I forgot
Yeah.
to write that. Isn't the derivative of g, which is the inside, 2x?
Yeah.
Yes. So that's where that comes from. So when I write these, when I write them, I typically sorry, I don't write them like the book does. I write them like, oh my gosh, my throat. I'm gonna sneeze or cough or something.
He's gonna you know when grown-ups where they sneeze, cough, and fart at the same time? She's gonna do that.
Okay, so if I did this problem, because right here, this is the derivative of the outside, yes?
Yes.
This is the derivative of the inside, and that's how we would write it if we were writing it, correct?
Correct.
So we're going to go backwards. We're going backwards, okay? So we're going to add 1
Right.
to the square and get what?
2. 3.
3.
Oh.
So that means I divide by 3, yes?
Yeah.
So that would be 1/3 x squared plus 1 cubed
Yeah.
plus c.
So we're...
Because now let's find the derivative of this. Okay? I want dx of 1/3 x squared plus 1 cubed. I want the derivative of that. So that means I bring the 3 out front, right?
Yeah.
So my 3 times 1/3
Is 1.
and then we have x squared plus 1 squared times the derivative of the inside, which would be what?
2x.
2x. So when I simplify that, this is 1, and I get x squared plus 1 squared 2x. What did I start with?
That.
Nothing went anywhere. Do you get what I'm saying? You said where to go. It didn't go anywhere. It's where did it come from? This 2x came from the derivative of inside here, didn't it?
Where did the 1/3 come from?
I gave you, this was our answer. This was our antiderivative. So to prove it, we took the derivative of the antiderivative.
Right, but originally, where did the 1/3 that's up front?
Where did this 1/3 come from?
Yes.
Because we divide by this.
Whoa.
Isn't dividing by 3 the same as multiplying by 1/3?
Yes.
Yes. So that's where it came from.
I'm flabbergasted right now.
Why?
So the 1/3 x squared plus 1 cubed plus c is our answer to that.
Mm-hmm. Because this right here is a derivative, correct? This right here is a derivative. That's why it says dx.
Yeah.
So when I take the integral, that's going backwards. It's going back to the original function. We're taking the antiderivative, or the integral.
Yeah, okay,
So this right here was the original function.
Okay, hold on. I understand how you found 1/3 x squared plus 1 cubed. I understand how you did that. 2x.
It's not where did it come from?
But like, I'm just saying, like, I'm probably gonna guess that all of the problems, they're gonna have something like this, but that outside number, is it gonna always be a part of that? Like, is the outside number always gonna be the derivative from that?
When you're doing this, yes, because you're using it on something you'd have to use the chain rule on. Substitution is used on stuff we have to use the chain rule on. And so you're always going to, we are going to change variables very soon, like very soon, like in 2 examples. And it might be a little bit easier to think about. Okay? So can we keep going?
I'm still... Okay, so I know that you added 1
Mm-hmm.
to them. So then the 2x just went into that?
Because when we do the chain rule, when we did the chain rule right here, yes?
Yeah.
The 2x came from the derivative of g of x, didn't it? Right here.
Okay.
That's where it came from. So when I'm going backwards, does it affect what I'm doing? I have to know that this was the derivative on the inside of the inside of the function.
Oh, okay.
So it doesn't change what I'm looking for. Does that make sense what I'm trying to say?
Yes.
Okay. So let's do another one. So I have the integral of 5 cosine of x dx. Now when we rewrite this, we should when I rewrite this, I'm going to put the integral of the cosine of 5x times 5. Because where did the 5 come from? Of 5x, right? So when I'm identifying things, f of x is the outside function. What is it? Cosine of x. What is the inside function?
5x.
5x. So let's look at this. What is f of g of x?
5.
That is, no,
Wait,
f
sorry.
of g of x would be cosine of
5x.
5x. Okay, so I'm just trying to get you to see that. Okay, so now what is
I don't like how the book writes.
the integral of the cosine?
Negative sign.
Not negative sign,
Just sign.
just sign.
So then the integral of sine is negative cosine?
Mm-hmm. So it's sine of 5x plus c.
On the test, are you gonna write the equations like how you write them, or are you gonna write them how the book writes them?
They're probably going to be written how the book writes them.
Why did we do the derivative of g on our first example, and this time we did f of g?
I know, we can identify the derivative of g. I'm just identifying different things. So the derivative of g is what?
5.
5. We're just at this point, we're identifying the different parts of this. Okay? I just want you to be able to look at that and see all those different parts and where they came from.
I just kind of want to like take a pause. I got my new glasses on. Don't they look cool?
Oh, I didn't even realize.
Oh, yeah. You didn't realize that there's no white tape in the corner.
Damn, they look like your old ones, so you don't like even like you can barely tell there's like lines on them.
Great, thank you.
Okay.
They're a lot thinner though.
Really?
Yeah.
If I stand up if I need to.
Okay. So I have the integral of x squared plus 1 squared dx.
Is this continued from the last example?
It's a new one.
She just made it up. Oh, look at her go. Look at her
Oh
go.
boy.
So, is that how the book writes it, or is this how you write it?
No, this is how the book writes it.
Okay, good.
Okay, but we need to think about some things.
Okay.
Okay? Well,
I'm listening.
f of x is what?
X squared.
Is x squared. Yes?
Yep.
G of x
Is x squared plus 1.
is x squared plus 1. The inside, right?
Yeah.
G prime of x is what?
2x.
That's 2x. You see a 2x up there?
No. Did the book mess it up?
No. Didn't mess up. It should be 2x, right?
Deleted.
I'm confused.
It got reduced. So if it got reduced, what's really there? What's also there?
Plus 0?
No.
No.
How do you get, there's a 1x. How do I get 2x to be 1x? What do I multiply by?
Half.
A half. So what I really have here,
Are you serious?
yep.
You're kidding.
What I really have here is x squared plus 1 squared times a half times 2x dx. Correct?
Why?
Well, because they only have 1. So in order to get just 1, there had to be a what hanging out? There had to be a half. Now, I can take that half and do what with it?
Put it up front.
It can go out front. So then I have 1/2, and I'm going to put brackets just to clearly separate it. So I need the antiderivative of what?
That's 1/3
1/3
x squared plus 1 cubed.
x squared plus 1 cubed. And so I have 1/6. Oh, I forgot my plus c. 1/6 x squared plus 1 cubed.
Why?
Why?
No, I'm just saying, like, why to me, you know?
Plus C.
You
Oh,
know what I mean?
plus c, thank you.
You're welcome.
So that was a missing factor, wasn't it?
Mm-hmm.
There was something missing that we had to pay attention to. How fun.
This is why I don't like math.
This is why I cry myself to sleep every night.
Yep.
Yup.
Okay. We are now going to change the variable.
When does math stop?
Never.
You say that with a sense of like pride and like amazement, and we are just scared.
My handwriting looks amazing. So. And that's why I know that I will never become a doctor, because my handwriting is just way too good to be a doctor.
Nice, nice.
So I don't have to go to med school.
I think you should go to chiropractic
Ayo.
school and solve my moderate to severe back pain.
This is like the third weird phone call I've had. Okay, so now we are going to change the variable rather than listing all that stuff and doing all that. So we're going to see if we can make this a little easier on ourselves. So I have the integral. And I would suggest leaving room like over here. Like, let me show you how I would write this on my paper. I'd probably put like number 1 or whatever. I'd leave a little gap, and I'd write the integral of the square root of 2x minus 1 dx. Yes? So back on the first slide, I told you it was the integral of f of u du, correct?
Mm-hmm.
Okay, u is the g of x, isn't it? U equaled, that's not a u. U equaled g of x, didn't it? And du equaled g prime of x. So we're going to identify those things. So u is what?
2x minus 1.
2x minus 1. Du
Is x.
no
Oh,
is 2.
why just 2? Oh, because it's the derivative?
Yes. Yes.
Huh.
We're good?
Yeah.
Everyone following?
Yeah. Are you following, Sadie?
Yeah.
Are you sure?
No.
Okay. Always putting forth their best effort and keeping a positive attitude is in Mrs. Mick's syllabus. I always look up to you. With your
Oh,
pink hair tie.
I'm like, what are you doing? Okay, now what do I want to do? I don't know. Okay, so I don't have a 2, do I?
No,
Yeah.
yeah.
No.
No.
In my thing right here, I have the integral of u to the what power?
Negative first? Half.
Half. Thank you. But I don't have a 2.
Well, that's too bad.
Yeah. I don't know what to tell you there.
Yeah, it's extra.
So you need to multiply it by 4? There needs to be a 4?
Well, there's
No?
there needs to be a what in there?
There needs to be a 2, but there
What did we just do on the last problem when there should have been a
We
2?
need to put a half.
We need a half in there, don't we? Yeah? We have 1/2 and then du. Because du was the derivative of g. Yes?
Yeah.
Okay.
Yup.
So now I want you guys to notice what happened. Okay. U was the g, yes? U is g.
Mm-hmm.
This is g of x.
Sure.
Yes?
See.
And this is g prime of x, and x actually dx also, because when we have that dx means derivative, yes? Okay, so I substitute 1/2 was still f. It's still there, isn't it? U was substituted in for the 2x minus 1, and we need this 2 there, but I don't have a 2 in the original problem, do I? So I had to put a what?
Half.
Half. Okay, so what happens to the half?
It turns into a 2.
No. What happens to the 1/2?
Goes up front.
Goes up front.
7.
So now I'm going to take the integral. So 1/2 plus 1 is
3/2.
3/2. So I have to multiply by that reciprocal, which is
2/3.
2/3 u to the 3/2 plus c. Correct?
Correct.
But u is not in the original problem. Now we have to plug back in what?
Half.
U.
Why?
We have to plug back in u. There is not a u in the original problem, is there? We changed the variable so it's easier to deal with, and now we're going to have to change it back. So 1/2 times 2/3 is what? 1/2 times 1/3. 1/3. What's u?
2x minus 1.
2x minus 1 to the
3 halves.
plus c.
That's our answer?
Yep.
Just leave it like that.
Well,
Easy.
Yep.
Easy peasy lemon squeezy.
Ready for another one?
why?
Is there another one?
Well, because the more we do together, the easier they hopefully are to do when you do them on your own.
Enough said.
I wish this were easier.
Was that the one we just did? No.
This will be a challenge, but we're determined to do it.
This will never work.
We just did that one. Right?
Yeah.
I think
someone can help me do this.
Yeah.
I'm not smart.
Okay.
And you'll keep learning and trying new things.
Let's go.
Have you caught on to that? Have you? She has not, and that's perfect.
Okay. I'm proud. You guys want to rewrite it?
Yeah.
Okay. Where should we put this x at?
You know,
In front,
that way.
Shouldn't it go behind? Like,
I guess.
Yeah, fine, whatever.
2x minus 1/2 2x.
because isn't x the derivative of g?
Yup. So yeah, are we doing the u and du stuff?
Okay, I'm in class. When are you coming back to school?
Okay, let's figure this out, guys. So u is gx, right? So would it be the one inside?
Yeah.
So would it just be 2x minus 1?
Yeah.
And du is the derivative of g. So that would
just
be
be 2.
2.
Yeah.
Is there a 2 in there? No, there isn't.
Somewhere. Maybe.
So now we have to find one, and we have to add a half. So, well, wait a minute. I will do this. So, so our new derivative will be u. Don't help us out, okay? U to the half. Anyone else want to put in their input?
No, I
Okay,
don't
great.
really know what's going on.
Then add a half. I'm just looking at the problem up above real fast. Then x. I don't know. Wait. Then put du afterwards. Why? I don't know. So now,
Okay, we got a problem though.
okay, hold on. Oh, what do you do with your x?
That's what I'm saying. We have a problem, don't we? Because the 2 has to be there, right?
Wait,
The-
no.
second. This 2 has to be there, correct?
Yeah.
And it's not.
Yes.
So you had to have 2.5. 2 times a half, correct?
Mm-hmm.
But you have what going on here? An x. We don't know where that x came from.
No.
Okay, do we have something right here that we could solve for x
Yes.
and substitute it in?
Yeah.
Yes. So we need to solve this for x. So how would you solve that for x?
X equals.
You would add 1 and divide by 2, correct?
Yeah.
So x would equal u plus 1 over 2. Would that allow us to change x into u?
Yes.
Yes? So I have u to the 1/2, took care of this, yes? 1/2 times 2 took care of this and the dx, correct?
Okay, but the last problem we didn't.
We didn't have an extra x. We didn't have an extra x.
Why is this so? Oh my god.
Okay,
Same.
No point. I quit. I give up.
That's it.
What?
That's too bad.
What? Sadie, come on, dude.
Shh.
That was banned.
Something's bothering me.
Huh?
It was
No, you're fine.
like,
Okay. So then we have to add in the u plus 1 over 2. Right?
right.
I don't know.
Not rotating it.
And where did the u plus 1 over 2 come from?
It came from how we find the x, yeah.
Oh, I forgot my du. Yeah?
Yeah.
Okay.
This is not okay.
Oh, wait, that extra 2 doesn't need to be that. That's stupid too. That is du, isn't it? Like right here. See that?
So we
du equals 2 dx.
So I was right.
I'm sorry.
Boom.
I was worried about that x.
Don't listen to her, guys. Listen to me.
Okay, we good?
Yeah.
Now we are.
Okay. So now, this is a half, and also this is a half, isn't it? Like,
Yes.
can I write that 1/2 times u plus 1?
Mm-hmm.
Okay, so I can bring out a half and a half as a what?
Ow.
Is 1/4.
1/4?
Yep.
Okay. So I have 1/4 the integral of u to the 1/2 times u plus 1 du.
Yes.
Probably need to do what with this u?
You need to put it inside. No,
And-
distribute it.
I need to distribute it.
Yes.
Are these problems going to take you to be methodical about steps?
I'm.
Okay, so I'm going to get u to the what?
1/4. No, sorry. I'm sorry.
There's a 1 here.
3/4.
How about 3/2?
3. Yeah.
Question.
What?
So, you got 1/4 from half times half, right?
Right.
Okay, so how you so I had half, then u plus 1. Is there a 1 in front of the u? Is that why you took the 1/2 out?
Well, yeah, because I can write this. Couldn't I write it as 1/2 u plus 1?
Yeah, I just got really confused because it just says u plus 1 over 2, and I thought you just took the 1/2 where it says 1.
Oh, no, I took both of them. When and I don't know why I wrote it, I typically will only write them like that.
So there is a 1 in front of the u.
Yeah,
Okay.
there's a 1. Okay, so then I get u to the 3/2 plus u to the half.
What? Okay. 2/3 you do the 3/2.
No, I haven't done anything. I haven't done that yet. I haven't taken the antiderivative yet.
What are you doing?
What's that?
We're distributing the 1/2 in. Okay, now do I do this separately like I've been doing?
Yeah.
Yes. Okay, so I'm going to have 1/4. I don't know why I just wrote it like that. 1/4. So I have 3/2 plus 1 would be 5/2, correct?
Yup.
So it's 2/5.
Yep.
U to the 5/2 plus 1 would be 3/2, so 2/3. U to the 3/2
Plus c.
plus C. And now I have to substitute back in what?
1/4. Oh no, your u.
My U.
2x minus 1.
Okay, and we also need to probably distribute the 1/4 in to those things, right?
Yes.
So 1/4 times 2/5, the 2 and the 4 reduce. So 2 times 5 is
10.
10. So 1/10, 2x minus 1 to the 5/2 plus 1/4 times 2/3,
1/6.
1/6 of 2x minus 1 to the
3 halves
3/2
plus c.
plus C.
What up?
Now, this was some work, but can you imagine what we would have had to do here? Like, and actually we couldn't have done it because we couldn't take x times something to the 1/2, could we?
Right, because we didn't. know
Because we couldn't do the square root. So we couldn't take the square root of this, and if we can't take the square root, then we can't multiply it. Okay, so I'm not going to do any more examples today. You have your assignment. A lot of your assignment today, I think, is just identifying the u, the du. If you want to keep going, you can find the antiderivative because you can check it on that integral calculator, right? Yes? Okay. There are, on Monday, you're going to do the Paul's notes, and the link is there. You're only going to do 1 through 7. If you want to go tonight because you're struggling or whatever, on Monday, whatever, that takes you to the practice problems, and right above it, it says notes. If you want to look at his notes, or if you just want to go look at his problems and how he did them, the notes might get kind of confusing when you're trying to read them. But there are lots of problems. Like in his notes, there's like 15 examples. We have not gotten, these are just the basic ones so far, okay?